Hello everyone, and welcome back to the next video. In this video we will be working on some practice problems on rearranging a formula and solving it for a variable of interest. What I'll do is I'll give you some 12 problems, and then you can pause the video, work out these problems, and then take a look at the solutions that I give in this video. Now, at times what I will do is give you alternative approaches, and in such cases I will indicate which approach is the better approach, and there are some approaches that should actually be avoided if possible because of the fact that they become very inefficient, confusing, and also sort of like a lot of semantics gets lost in the way. Okay, so here's the set of problems. So there we are, there are 12 of them. You have so each one should be solved for the variable of that's indicated, such as for number 1, for example. The formula is m1v1 is equal to m2v2, and we want to solve this for v2. Okay, go for it. Okay everyone, so I'm pretending now that it's sometime later, and we are back. And so the solutions to these problems: for number 1, m1v1 is equal to m2v2. And for number 1, alternative 1, which is what I recommend, is to take v2. Imagine v2, you want to isolate v2. It's within a term, of course. The term is isolated already. So we now look for the factor, and we isolate the factor v2. And because m2 is being multiplied by, you move it over here, and you divide by it. So v2 becomes equal to, we have m1v1, and then m2 comes down and divides. Okay, so you can actually do this in one step. Keep in mind, these kinds of formulas are quite common in physics and also chemistry and basic science formulas, basically, where you have two variables and there are initial values and final values, and when you multiply them, you get equal amounts. So this is not just one kind of formula that you see. If you can work with this formula, then any other formula that's similar to it is something you can tackle as well. Okay, alternative 2. Oh, by the way, and you can also write this down in a different way as well. Remember, in the previous video I did indicate that writing it this way is actually better because of the fact that it shows that the speeds are related through the ratio of masses in this manner. Okay, alternative 2 is if you find it difficult to move m2 down and at the same time switch sides to put v2 on the left side, what you can do is you can switch sides and then take m2 and move it down. You're multiplying on the left, you divide on the right. And again, you can write it down as m1 over m2 times v1. Okay, alternative 3. Now again, we switch sides, but this is for people who would like to follow the kind of logic that says you should do the same thing to both sides of the equation. You still have to realize that you have to solve for the term that contains the unknown, which is done. And now you're looking for the factor that contains the unknown. And because m2 is being multiplied by, we divide both sides by m2, and that way we get rid of m2. So we get m2v2 over m2 is equal to m1v1 over m2. Now on the left side, the m2's cancel out, you get 1 and 1, and you end up with v2. And on the right side, you get m1v1 over m2, and as usual, you can also write it down as m1 over m2 times v1. Problem number 2. T is equal to 1 over f, and we want to solve this for f. And so alternative 1, which is recommended, is we'll take division by f here and turn it into multiplication on the left side. Now again, before you move factors diagonally, by the way, you have to make sure that you only have one term. So here we do have one term, and now we see one factor on the top in the dividend and one factor down here in the divisor. We take the division by f here and turn it into multiplication by moving it up diagonally, and then because t is being multiplied by, it moves down and goes where f is now. So basically t and f switch sides. They move diagonally, and we end up with f is equal to 1 over t. and you're done. Alternative 2, crisscross approach. So if you want to follow that approach, then you would see t as t over 1, and then you would multiply t by f and 1 by 1. And in that way you'll end up with t times f is equal to 1 times 1. And of course the reason you can do that is because you're turning division by f on the left to multiplication on the right, and you're turning division by 1 here to multiplication on the sorry about that, f becomes multiplication on the left, moves left to the top, and 1 multiplies 1, division by 1 here becomes multiplication by 1 on the right side. And so a shorter way of writing it down is tf is equal to 1. And now you have one term on the left side, and so you solve for the factor that contains the unknown. T is being multiplied by, and so we divide both sides by t. On the left side the t's cancel out, and we get f. And we get f is equal to 1 over t. Now you could shorten this. Steps 2 and 3, normally people don't write them down. You imagine that you do have the 1 under the t, and then when you multiply t by f, you just write down tf. And when you multiply 1 by the imaginary 1 here, you just put down a 1. So normally you find that these two steps are not written down, and people jump from here to here, which makes it a bit more efficient. But still, it's nowhere as good as the one where you just turn division by f into multiplication and multiplication by t into division and jump to the final line. Problem 3, q is equal to mc times t2 minus t1. This has to do with the heat that enters an object and changes its temperature. Now we want to solve this for c. And here alternative 1, which is recommended, let's switch sides, bring unknown to the left. mc times bracket t2 minus t1 equals q. And now there is one term on the left, so the term that contains the unknown has been solved for. We look for the factor that contains the unknown. M is one factor, c is the other factor, the second factor, and the brackets are the third factor. We are multiplying m by c by the bracket. So 3 factors. And we want to solve for the factor that contains the unknown, which is c, because m and the brackets are being multiplied by. On the next line, on the other side, we divide by them. So m times the bracket, t2 minus t1 moves down, and you're done. Okay, alternative 2. Hopefully you will switch sides, keep the unknown on the left. That's very good practice. But now again, you still have to go through the logic that says that you have solved for the term that contains the unknown, and now you have to solve for the factor that contains the unknown, and so that logic still has to be sort of dealt with. But the issue is that once you realize that you're solving for the factor that contains the unknown, with the other approach, which does the same thing to both sides of the equation, instead of taking m times the bracket and moving the whole thing down, you would divide both sides by m and the bracket. So you would write something like this down. We want to get rid of m and the brackets, and so we divide by that. We do the same thing on the right side. On the left side, m's cancel out and the brackets cancel out, and so we end up with just c. And on the right side we get q over m times t2 minus t1, which is pretty much what happened in the end, was m and the brackets moved diagonally down. Now this step, you can even make it more of a step-by-step approach by first dividing by m only, and once you get rid of m, then you divide by the brackets on the next line, which makes it even longer now. It definitely is not an approach that I would recommend. Number 4, now we want to solve for t1. And alternative 1, which is recommended, switch sides. Now, again, there is only one term on the left. So the term that contains the unknown has been solved for. And it has 3 factors, m, c, and the brackets. The unknown that we want to solve for, t1, is in the third factor. It's within the brackets. So we solve for the brackets. M and c are being multiplied by. On the right side, we divide by m and c. So t2 minus t1 is equal to q over mc. Now we take T2 and move it over to the right side. Put down negative T2 plus Q over MC, and then deal with the sign. When you deal with the sign, if you need to get rid of a negative sign, you can multiply the equation through by -1. Or you can take the -1, which is actually this negative is actually -1 times T1. So you can divide the right side by -1. And when you divide by -1, what happens is that the sign of every term switches. So so basically the shortcut is if you change the sign here, you have to change the sign of every term on the other side. Okay, so T1 becomes equal to T2 minus Q over MC. All right, alternative 2. Now again we switch sides, but this time we divide both sides by MC. Again, you have to go through that same argument that you have to solve for the term that contains the unknown, which is done, and now you have to solve for the factor that contains the unknown. And so to solve for brackets, you have to get rid of MC, because M and C are being multiplied by, we divide both sides by MC. On the left side, MC cancels MC, and we end up with T2 minus T1. On the right side, Q over MC. Now T2 moves over, and at this stage, by the way, again, if you insist on doing the same thing to both sides of the equation, at this stage you would subtract T2 from both sides, because T2 is being added. So you are back to now solving for the term that contains the unknown. That would be T1. And term T2, because it's being added, there is a plus here. We move it over and make it minus. So negative T1. So we subtract it, and we get T2 minus T1 minus T2. That will get rid of plus T2 here, and we do the same on the other side, minus T2. Now T2's cancel out, and keep in mind we'll end up with negative T1 is equal to Q over MC minus T2. Now once again we change the signs, and hopefully you will follow good practice and rewrite it in this way. Again, not an approach that I would recommend. Okay, alternative 3. Please avoid this one. Multiplying MC into the brackets is not a good idea. You can do that, MC times T2 and then MC times T1. But the problem becomes much more complicated. Now, you might say that you've been told that you can multiply into the bracket, and so you might wonder, then under what conditions would you take that kind of a step? And the answer is, and remember this, if the unknown appears only once throughout the equation, there should be no need to multiply anything into any brackets. The case when you multiply into the bracket is when the unknown appears multiple times, and you have to open up the brackets and regroup and put your x's together. But if x appears only once, there is absolutely no need to multiply into the bracket, and in fact it's not a good approach. You're going to see how complex this is going to become. So now we solve for the term that contains the unknown. Our aim is to solve for T1, so we solve for the term that contains the unknown. MCT2 moves over, becomes minus. And if you insist again on doing the same thing to both sides, then at this stage what you would do is you would say, well, if I'm solving for the term that contains the unknown, that's MCT1, I have to get rid of MCT2, and because it's being added, we subtract it from both sides of the equation, and so we have minus MCT2 minus MCT2. Now MCT2 cancels with minus MCT2, they generate 0, and we'll be left with negative MCT1, and so we get negative MCT1 equals Q minus MCT2. Now we solve for the factor that contains the unknown, which is T1, and that means we have to get rid of negative MC, so we divide both sides by negative MC. On the left side they cancel out, we get T1. On the right side now we have this complex looking, these signs that have not been cleaned up, and we have to break this expression into two parts to sort of clean it up. On the left side now MC and MC cancel out, and these two negatives become a positive, and so we end up with T1 equals negative QMC, and if we turn this into a plus and cancel out the MCs, we'll be left with T2, which again you can rewrite as T2 minus Q over MC. You can see how complicated this is becoming, and that was one of the points that I was making, that adopting approaches that are inefficient, eventually, as things become more and more complicated, the best of the approaches will continue to shine. And as your approaches become worse and worse, as the techniques that you use become less and less efficient, that inefficiency will only grow in magnitude. And the worst part of all of it is that so much meaning gets lost in approaches that are not standard. All right, problem 5, area of a trapezoid. Area A is equal to 1/2 times B1 plus B2 times H. And we want to solve this for H. So let's switch sides. Now this time I'm going to show you only the best approach. We switch sides. And then solving for H, we solve for the term that contains the unknown. There is only one term on the left, so that's done. Now we have to find our factors. If there is division, find the factors in the dividend and also the divisor. So 1 is a factor, 2 is a factor, the brackets are factors, and H is a factor. We are solving for the factor that contains the unknown, that's H. 2 is being divided by, it moves up and multiplies A, so we get 2A. And the brackets are being multiplied by, they move down and divide. And we get H is equal to, so again, 2 moves up, and the brackets that are being multiplied by move down, B1 plus B2. Okay, same formula, and this time we want to solve for B1. And so again we switch sides. Now we solve for the term that contains the unknown, which is already done. And there are 3 factors, 1/2, brackets, and H. And the factor 1/2, it's got 1 factor on top, 1 factor down. We solve for the factor that contains the unknown, which are brackets. 2, which is being divided by, moves up and multiplies. H, which is being multiplied by, moves down and divides. So we get B1 plus B2 equals 2A over H. Now B2 moves over. So we solve for the term that contains the unknown. And that's the end of it. Okay, let's move on to the next problem. M is equal to negative P over S, and we are solving for P. Alternative 1, which is recommended. Now, in terms of the negative sign, before we start moving things around, I should mention that when you have the negative of a fraction, it doesn't really make a difference whether that negative sign is on top or down or on the side. These are all the same. So the top one, for example, it says that you have a negative number divided by a positive number, so the answer will be negative. And 1 divided by 2 as a decimal, for example, would be 0.5. So that's equal to negative 0.5. The second one, now you have positive divided by negative, but it's still negative. And 1 divided by 2 is 0.5. So that one is also negative 0.5. The third one says that you have a negative number to begin with, and the size of it is 1 divided by 2, which is 0.5. So again, we get negative 0.5. So you can see it doesn't make a difference where you put your negative sign. Now, having said that, the top one is easier to work with, usually. The bottom one, often avoided, although here it's actually where we will be using it. And the third one, usually when you report your final answer, it's better to write it like this, so people know that they have a negative number whose size is 1/2. It's the most descriptive way of saying it. Okay, so here we can associate the negative sign to P or to S. Because I'm solving for P, I'm going to associate the negative sign with S, and then negative S, which is being divided by, moves diagonally up and multiplies. So let's switch sides. And now we associate the negative with S, and then we move it up and multiply the right side by it. So we get P is equal to negative SM. Alternative 2 is to use crisscrossing. So we imagine we have a 1 under M, and then now again, depending on whether you associate the negative with P or S, you can make it easier or more complicated. Here I went with the more complicated way of associating negative with P and just moving S, doing S times M, and then 1 times negative P. And then you have to get rid of the negative sign by either switching sides or by moving negative P over and SM as well to change the sign, or multiply through by negative 1. Okay, now same formula. This time we want to solve for S, and this time I will use the better approach. Basically, I associate negative with P, and then S, which is being divided by, moves up. M, which is being multiplied by, moves down. Your other option would be to use crisscrossing. Okay, problem 9. Again, as usual, these formulas that you see, the forms that you see, are common. That's the good news. It's not like every formula is different from every other formula. This formula, there is a different version of it, where you have V is equal to D2 minus D1 over T2 minus T1. There is the acceleration formula. A is equal to V2 minus V1 over T2 minus T1, and there are others. So if you know how to deal with one, then it's like you know how to deal with all of those. Okay, now for these, I will stick to the better way of doing them, because as formulas become more and more complex, as I mentioned, these other less efficient approaches become really time consuming and confusing in terms of all the signs that you have to clean up and fractions that you have to break up. So here we have E2 minus E1 over T2 minus T1. Of course, I cannot move T2 up, because I'm not dividing by T2, I'm dividing by T2 minus T1. This is a multiple term divisor. But I could imagine that all of T2 minus T1 is inside brackets, and that would make it one factor, one term. And so the whole thing can move up, and we get E2 minus E1 equals P times, for sure you need brackets, T2 minus T1. The only time you don't need brackets is when the thing that you move is only one term or part of one term. Now solving for E1, we move E2 over and put down negative E1 equals negative E2 plus P times T2 minus T1. And now again, we change the sign here, here, and here. And so we get E1 is equal to E2 minus P times T2 minus T1. Right, number 10. Now this time we're solving for T2. And here what I do is, again, I imagine that T2 minus T1 is in brackets. That makes it one term, one factor. And the whole thing, which is being divided by, moves up and multiplies. And then P, which is being multiplied by, moves down and divides. So we can write down T2 minus T1 equals E2 minus E1 over P. And the other alternative is to write 1 over P times bracket E2 minus E1. Both are common. You should really feel comfortable with both of them. Okay, now solving for T2, all we have to do is move T1 over, and we get T2 equals T1 plus E2 minus E1 over P, or T2 equals T1, and then we have the other version plus 1 over P times E2 minus E1. Problem 11. E is equal to 1/2 mv squared, and we want to solve for V. So let's switch sides. Now there is only one term on the left, so the term that contains the unknown has been solved for. We have three factors, 1/2, m, and v squared. In addition, 1/2 has one factor on top, one factor down. So diagonal movement is allowed, and what we do is we solve for the factor that contains the unknown, that's v squared. 2, which is being divided by, moves up and multiplies. M, which is multiplying it, being multiplied by, moves down and divides. And we get v squared equals 2e over m. Now we have solved for the term that contains the unknown and the factor that contains the unknown, and that means that repeating these steps will not give us anything new. So now we move to the to deal with the exponent, and here we have a missing base, which indicates that we should use roots, and so v becomes equal to, for an even exponent, positive or negative root 2e over m. But we know that v, being speed, cannot be negative, and therefore we drop the negative and keep only the positive. Okay, one more problem. N is equal to 2 to the power of n times n0, and we want to solve for lowercase n. Let's switch sides. Now this is alternative 1, which is recommended. And there is only one term on the left, so the term that contains the unknown has been solved for, and it has two factors. The first one is 2 to the power of n. The second one is n0. These are the two things that we are multiplying. And so we solve for the factor that contains the unknown. That would be 2 to the power of n. Because n0 is being multiplied by, on the right side we divide by. Now we have solved for the term that contains the unknown as well as the factor that contains the unknown, and repeating these steps will not change anything. We move on to deal with exponents, roots, and logarithms. In this case, because the unknown is part of an exponent, we'll be using logarithms. So n becomes equal to log to the base 2, that's the 2 here, of n over n0. Please make sure that you write 2 as a small number subscript, because otherwise it can make a difference in reading. The value actually changes if 2 becomes part of the number that you have here. Okay, so that's one way of doing the problem. That's the best way of doing the problem. Another way to do the problem for people who like to do the same thing to both sides of the equation. Let's switch sides. And now we still have to argue that we solve for the term that contains the unknown, and now we solve for the factor that contains the unknown, which is 2 to the power of n. You still have to recognize that you are multiplying by n0. But instead of turning multiplication by n0 to division, this is where the difference comes in. You divide both sides by n0. On the left side, n0 is cancelled out, and you get 2 to the power of n equals n over n0. Okay, now we need to deal with the exponent now. And so we have to use logarithms, but what we'll do is we find the log of both sides. So we write down log to the base 2 of 2 to the power of n is equal to log to the base 2 of n over n0. Now you should be aware of an identity in math, where if the base here is the same as the number that you have here, then the two of them cancel out, and you'll end up with n. Basically this side, what it says is, what is the exponent of 2 if we want to get 2 to the power of n? And the answer is n. So n becomes the log of log to the base 2 of n over n0. Okay everyone, thank you very much for watching this video, and in the next video I'll talk about some of the applications of formulas and rearranging them. We'll be taking a look at some word problems whose solutions require the use of a formula. Take care everyone, and see you soon.